The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So there's two main things that we're going to start with today. One is we're going to review the quiz, and we'll be real quick on that. Then we're going to talk about object-oriented programming, which is something that you'll probably be more interested in for your problem set. So just going down problem one, it's false, true, false, false, false. Does anyone have any questions on this? No? Everyone good with that? Anyone wonder why something's true and why something's false?
Why is the second one false?
Why is it false? It's true. Because, and this is an English thing, or a language thing, so it can kind of trip people up. But it's basically saying that there are some problems that you need to use recursion or iteration to solve.
Well, you always have to use. Why would there be a problem that you cannot solve without using?
Well, if you have a large number of inputs, or the inputs are variable, I mean, the point is that there are certain problems that you would need to use recursion or iteration to solve them. There are some that you don't, but this is just asking if there are problems that exist.
And use brute force?
Well, brute force usually involves some sort of iteration, because you have to iterate through all the possible solutions. Any other questions? Okay. So the next one, this was just an exercise in code reading, and we can actually just look at how it runs. So if I run it like that, also if you don't have your quiz, I have them up here if you want to pick it up. But that's just the output of that code. Does anyone not see how that works, or want me to step through it? Okay. Okay, question 3 was the double recursion question. And those are the two answers we were looking for. Does anyone not see how that works? Or want to try and walk through it? Okay. So the way to tackle this problem is just, you got to step through or kind of walk through it in your head, right? So let's take the first set of input. All right. At the top, that's your initial call. Now, the string S here is not less than 1, right? So you're going to go to this double recursive call here. So that means that you're going to get as your return, right? And the way I got this AT is I'm just taking S from 1 to the end, okay? So what this means is that this part is going to execute first. And it's the same thing. Go into the function. This is now S. This is obviously not only 1 character long, so we're going to have, again, another double recursive call. And it's going to look like this. All right. So now I've got this call to contend with. Now this string is 1 character long, so what does it do? It just returns the input. So this function call is just going to return t. And then this function is going to get called with t again. And we already know what happens when you pass it t. That means that this whole function here results in t, right? And then we tack on the a, so that means this function call at returns ta, and then we pass it into this outer function here, all right? And we can already kind of guess what this is going to return, because for this input, it just reversed the characters. It just flipped them. So for ta, it's going to flip them again. So the entire function call here results in AT. And then we just append m to it, so the entire return for this one is ATM. So it's tricky, but you've just got to step through the code and step through the functions and look at at each step, what the function is getting as input. This was the coding question, right? Most of the questions up until now have been, can you read code and understand what it's doing? This one asked you to actually implement a function. And when you start with these questions, you should always start from the specification, right? So this function is assuming that we have a list of words in lowercase. Elster is a string of lowercase letters. All the letters in Elster are unique, and that the return of the function are going to be all the words in word list that have a one-to-one mapping between the letters in the word and Elster. So in English, let's say that my Elster is raft, okay? And assuming that I have a fairly complete word list, I'm going to have 2 words that are going to meet that criteria, right? I can say there's an R, A, F, T. That's pretty obvious. And we have a T, F, A, R. So that's what we're looking for. So a lot of you did something where you iterated through all the words, and then you had another loop inside that tried to find this correspondence. The way that we solved it, and there are multiple solutions to this, so if your solution worked, you got full credit. But the solution that we came up with is, first, we're going to take the letters in Elster, and we're going to sort them. So we're going to have A, F, R, T, right? Alphabetically. And then for each word in word list, we're going to do the same thing. All right, so raft becomes AFRT, fart becomes AFRT as well. Then it becomes just a simple string comparison. And all we have to do is iterate through the word list. All right, does that make sense to everyone? So our solution has a trick. You don't need to use this trick. A lot of people didn't, and they got full credit. But this is one way of doing it. All right, so question 5. This was the one where we asked you to find the problem with this code. Or rather, we asked, does this code meet the specification? And so when you get a question like that, the first thing you should do is actually look at the specification, right? And you should look for what this code needs to do, because the specification is going to tell you what the function needs to do. If it doesn't say you need to do something, then that means it's undefined, right? So in those cases, you can do whatever, as long as you meet the specification. So the first requirement is it returns a list of the pointwise sum of the elements. So that's the first requirement of the specification. And then it gives you 2 kind of implicit requirements. One is this example where it says, if I'm given 2 vectors, this is what I expect the return to be. In this case, the vectors are 2 different lengths. So it's also saying that your vectors are not always going to be the same length. And in that case, you take the pointwise sum up to the shorter of the 2 lists and just tack on the remainder from the longer list, okay? So that's the second requirement. The third requirement is if you have 2 empty lists, you're going to return an empty list. And finally, your fourth requirement is does not modify inputs. So now you know the 4 requirements from the specification. And now you need to look in the code and see if this code matches all those requirements. So the first one, does it return a list containing the pointwise sum of the elements? Well, this is the portion of the code that does that. And it looks like it meets that specification, right? result is going to be the longer of the two vectors. So in this case, if v1 is longer than v2, we set result to v1 and other to v2. That's the shorter. And then if v2 is the longer, we set result to v2 and other to the shorter of the two vectors. Does everyone see that? So we iterate through and we get the pointwise sum. So we meet the first requirement. The second requirement is that if we're given two vectors that are of different lengths, then we're going to sum up the furthest that we can, so up to the length of the shortest one, and then tack on the remainder. Well, again, this for loop here that does a pointwise sum, it only goes up to the length of the shorter list, right? So second requirement met. Third requirement, two empty vectors returns an empty vector. Well, if I have an empty vector here, this is going to be 0. This for loop's never going to execute, and my result is going to be empty. Okay? And then finally, that leaves the fourth requirement, does not modify the inputs. Well, what's result? Result is what we're ultimately returning. And that's the only thing that we really modify in this function. Well, result in this case is v1 or v2, but they're aliased. So it's modifying the inputs, and that's the violation. So the answer to this problem is a total of 6 characters. Some of you wrote like entire redefinitions of the function or like copied Ryan's code from the reviews. Perfectly acceptable, but way too much work. Remember, programmers are lazy. So that's all we were looking for. If you use the code from Ryan, or you had a different implementation that met the specification but was completely different, you got full credit. So, you got a question?
Initially, when you went through this and did the v1.copy approach to the implementation, I think they got points off for it. I was just trying to figure out what the distinction is between doing a full slice and doing a .copy, and why one was better than the other.
.copy applies only to dictionaries. So if we try and do a .copy on a list, got it? So I think we took like 1 point for that or something. It wasn't like we knew what your intent was, but you just, blah. You didn't have your IDE there with you. All right, so question 6 was another exercise in code reading. And the way that I would attack this one is to figure out what the two functions do first. So let's take the easier of the two, add up. Takes a dictionary as input, and it has a variable result that it initially sets to 0, and then it iterates through all the keys in the dictionary and adds them to result. So basically, it's assuming that the values in the dictionary are insert or some sort of number, and it's summing them up and returning the total. And then this f function here takes in a dictionary, it zeroes out any of the keys it might have, and then it iterates through all the characters in S. And if the character is already in the dictionary, then it's going to add 1 to it, so it's going to increment it. And if the character isn't in the dictionary, then it's going to set it to 0. And then it's going to return the resulting dictionary. So knowing that, the function becomes pretty easy, right? F of A, B, B, C for D1, which is an empty dictionary. Well, just walking through it, well, we don't have to, but if we, starting from this point, if we iterate A, it's not going to be in the dictionary. So we're going to set D of A to 0. Then we move on to the next character, B. B is not in the dictionary, so D of B becomes 0. Now we move on to the second B. B is now in the dictionary, so we increment B, right? So now D of B is 1. and then we move on to the final character, C, again, not in the dictionary, so we set D of C to 0. Then we return the dictionary. So that means that in my dictionary, I have 3 keys, A, B, and C, and they have values 0, 1, and 0, respectively. So add up is going to return 1, right? And same process for all of these. Question I have here is, what happens when Python gets to that line? Anyone?
Oh,
It's going to be an error. Why? Right, its result is a local variable to add up.
yeah, there's no value outside the function.
So, there we go. All right. We're doing good on time. So again, the approach to this problem is to figure out which each of the functions do, and then walk through the code. Did anyone have trouble with this or want me to actually step through it? All right. All this does, this loop here, well, first, when f gets an integer, it just prints out the binary, the integer in binary. And then this loop here prints out the binary representations from 0, 1, and 2. So why is the first output none in this case? Because in that instance, in that first iteration, I is 0, right? So when f is called, n is going to be 0, it's just going to return nothing. So it gives you none. All right. Now the next question was, and I don't have it here. You know, under the assumption that log base 2 is O of n, what is the order of the function f? All right. And to figure this out, you know that this function here is O of n because we told you, right? And we know that that's one of the first things that's called an f. So automatically, our runtime is O of n. Now, this loop here iterates how many times? Log n, right? Well, log base 2n to be explicit. So for this function, which is the dominating term here? Right. So when we want to say O of n, it's just going to be that. If you had O of n plus, log n, I think we took a point, but just because when we talk about worst case scenario, we're looking for what the dominating portion of this function is. All right.
How does f of n return the binary?
How does it do it? Oh, you want me to walk through the code now? All right. First thing it does is it gets something it's calling cur digit, all right? And all that is if you take the log base 2 of a number, you're going to get the number of binary digits in it, all right? So think of it as like if I have 3, which binary is 1, 1, yeah. If I take log base 2 of this, then my cur digit is going to be 1, I believe. So I'm not sure what Python's going to round to. No. 1.5. But if we can truncate it to an int, it's going to be 1. right? So that gives us, that's kind of like our position marker in the binary number. And then now we're going to iterate while the current digit is greater than or equal to 0. So we're basically going to start here and then move down the line in this direction. And all it does is says if my n mod 2, so I'm checking to see if it's odd or even, like it's going to be 1 or 0. In this case, it's going to be 1 to the power of the current digit, which in this case is 1, or I'm sorry, misspoke, n is 3. So the remainder is going to be 1. In this case, 1 to the power of 1 is going to be 1. If that's less than n, which it is, then my answer is going to be ants plus 1. So I'm going to append 1 to this string that I'm constructing. And then I'm going to subtract whatever this, this part is. So 2 to the cur digit, in this case, 2 to the 1, it's just going to subtract this off, right? And then cur digit is going to be decremented and moved here. And then in this iteration, cur digit is going to be 0, and n is going to be 1. So 1 mod 2 is going to be 1. Cur digit 1. Cur digit is 0, so that's going to be 1 less than 1. Yeah. So it should print it out. I was not prepared for that. All right. So the final question, number 8. So big O notation, if we match it up, does anyone know what it is?
Upper bound.
Yeah. A lot of you put the expected running time, and the letters are messed up on this, but a lot of you put the expected running time, but when we are talking about big O, we're talking about worst case scenario. So that's the upper bound. There is an expected bound, so if you decide to do any more algorithm analysis, you have big O, expected, and little o. So like if I plot the runtime of a given function, like my big O might be this, the worst time, my expected might be like that, and then my absolute best case might be like that. So when we say big O, that's what we're looking for, or whatever it is. All right, Newton's method. What is that an example of? Yeah. These don't look right. You know what? I'm sorry. This is a different version of the quiz, so. So Newton's method, yeah, that's an approximation. And then the last one was recursion on your test. So the answer we were looking for was induction. So that's that. Anyone have any actual questions?
Go back to
Number
number 4.
4?
Yeah, because this is the last one.
Why is this? Okay. So what was the part that you didn't understand with number 4?
I guess I was kind of confused about how to join the words together, or like how to go through them to see if you know exactly which one went through each letter.
Well, that's kind of the trick we have here. So we know we have a list of words, so to iterate through the words, it's just a for loop, right? So that's what that for word and word list does. To do the thing where you match the letters 1 to 1, what we implemented here is we first take Elster and we sort the characters in Elster, and then what we do for word list is for each word, we sort that word, sort the characters in that word. And what that does is it allows us to just directly compare the two strings. And if they're equal, then we've met their criteria for adding it into the word list. or the return word list. All right, we good?
Yeah.
All right. So that's the quiz. If you don't have it, you can come pick it up.
So I was just gonna ask you, on that one, if you're getting the sorted string, you're concatenating this sorted string to this empty string. Well, why can't you just set it equal to the sorted string? Because there's something about the way that function operates that keeps you from doing that.
Yeah, so if I say my string is A, B, C, D, E, F, and I just say sorted S, this returns a list. What I'm doing with join is I'm just converting it back to a string. Got it? Okay, so on to object-oriented programming. So what can someone tell me about classes? What do they allow you to do?
They allow you to define a custom type.
Yes. So one thing they allow you to do is define a custom type. Now, when you define a class, you can group your methods and data together. It's something called encapsulation, right? So first off, we've actually already been using classes. We didn't tell you, right? So ints, floats, dicts, etc. These are all types of classes, right? And each of these, we've already seen them, have something called methods associated with them, right? Methods are basically functions that are associated with a given class. So, for example, if I have the str class, which everyone's seen, then it has, say, a method .lower. So if I have s equal, well, let me write it up here on the code. If I say something like s equal a, b, c, d, e, f, I can call the method lower. So we've actually already been doing object-oriented programming, you just didn't know it. Along with that, classes have methods and they also have something else. Someone help me? What?
Like parameters, variables.
I'm looking for something, so terminology-wise, attributes. So they're a way of grouping methods and attributes, right? So when we talk about attributes, we're talking about things that pertain to a specific instance of a class. So let's say that I have a real world example. I have a person class, right? We've already kind of seen this guy. A person has multiple instances. So there's an instance of Mitch. There's an instance of Garthi. There's an instance of Philippe. We're all people, all right? Mostly human. And we all have attributes. So, we all have an age, like when we were born. We all have a name. Some of us have hair and other attributes, right? We also have actions that we can take. So I can talk and I can walk. I can talk to you, 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 and you. All right, so a method that I could define for a person might be talk to someone, right? So, that's one way of thinking about objects. So object-oriented programming also gives us something called inheritance, right? So I could think of, if I'm going along with my person analogy, I could think of subclassing person if I'm willing to draw a hard binary on the genders. You have males and you have females, right? And in this column, I might have Tracy. I'm just picking on people who come to office hours. And then Dorothy, etc. Now, the inheritance portion of it is important because I've already said that one of my methods on a person is I can talk to people. I can talk to other people. It shouldn't matter if I'm talking to Garthi as a male versus Tracy as a female. Like, I talk to people basically the same. So that gets into something called polymorphism, which is we treat objects with a common superclass the same as, their subclasses. So as another example, let's say that I have, dogs and, I don't know, what's another canine, foxes. I'm not going to necessarily talk to canines the way that I talk to a person. So they would exist with a different superclass. And then we could all be animals. So really what object-oriented programming gives you is a different way of thinking about how you're modeling your world, all right? And what I want to do is now, instead of just talking about kind of these abstract things, kind of walk through some concrete examples. So the first thing that I want to illustrate is, let's say that we want to create a person, but we don't want to use object-oriented programming, or we don't want to use classes. Professor Guttag will get angry at me if I say we're not using object-oriented programming. So let's say I have a function make person, and I'm going to represent a person as a dictionary that has the keys name, age, height, weight as keys, right? All make person does is it takes these things as parameters, makes a dictionary with them as values, and then returns the dictionary. Right? Then I have a bunch of helper functions like get name of person. All that does is it just returns whatever's in the name key. I can also set the name in case the person decides that they don't want to be known as Mitch. They want to be known as Mitchell or something like that. So I have a bunch of these getter and setter functions. These are called accessor and mutator functions. Whatever terminology you want to use. I can also define another function that will do something like print out the person. So in this case, I'm just going to print out name, age, height, and weight. And to see this in action, I'm going to make a person, Mitch, 32, 70, 200, and then Serena, 25, 65, 130. I don't know if these are actually correct, so don't quote me on it. I have a syntax error. So if I run this, then all it's going to do is just print out what I'd expect it to print out, right? So I can also set my age, so I can go back in time to 25, which is a great age. And now I'm 25, all right? Now, this is fine if you just want to do simple things, but the reason why we kind of like object-oriented programming is because we run into difficulties. So let's say that I print out the type of Mitch. It says I'm a dict. But it doesn't give me any more information. So that means that I could define any random old dict and pass it to some of my functions that I've defined to work on people. And it'll probably give me an error. It also makes other operations kind of non-intuitive. So let's say that I want to figure out if two people are equal. Well, I could do that by defining a function people equal, or equal people, and passing it into person 1 and person 2. And for our intents and purposes, it's just going to be if they have the same name, they're the same person. So this is going to, of course, do what we expect it to do and return false, right? Because Serena and Mitch aren't the same person. But it's kind of awkward, and if we do things using classes, it becomes a little bit more elegant, and you get a lot more power. So let's say I do the exact same thing with a class, all right? So I have the class keyword, I have the name of my object or my class, my new type, and then I have this thing called init. All init does is it says, when I get a new person object, Python automatically calls init with whatever parameters are specified and tells the object to make attributes or to set itself up. So in this case, I need a bigger screen. I'm making a Mitch person, all right? And the way that you make a new object or an instance of person is you have the class name, and then you pass it whatever parameters are specified in init. Now, behind the scenes, Python will create a chunk of memory, and then it'll call this an init function, and it'll pass a reference to that chunk of memory. All right, so visually, let's say this is your magical memory. Python sees this call person, goes in, grabs a chunk of memory. This marker sucks. Grabs a chunk of memory and says, this chunk of memory is of type person, right? Then it calls init, and it says, basically, Mitch is a reference to this chunk of memory. All right, this is the self parameter. And then it has the other parameters. All right. And then in the init method, all we're doing is we're creating new attributes on this chunk of memory. So we're going to have an attribute name. We're going to have an attribute age, height, weight. Okay? And then we have a bunch of accessors or getters, mutators or setters. The same exact thing as the functions that I showed that we had when we were trying to do this without classes, right? The difference is that these are lexically scoped to person. They are methods for an instance of type person. Whereas before, they were just functions that worked on something we called a person, but a person was actually a dict. So let me just run this. So if I run this, I'm just going to create a person Mitch, or a Mitch person, and a Serena person. I'm going to print out Mitch. And it's the same thing that I had before, right? Except I'm using a class. Now, if I want to use one of the accessors, so I want to get younger again, I can just take my object, Mitch, and I can call the setAge method and pass it in my new age. And I've lost 7 years. All right. Now, so far, this is just a different way of doing kind of the same thing, right? But if we look at the type of Mitch, I'm a person, right? So there's now some extra information that we didn't have before when we were using a dict to represent a person. You know, before it could have been any dict. We didn't know that it represented a person. The only reason that it represented a person before we used a class was because we had set certain keys to certain values. But other than that, it was just a dict. Here, this is marked as being a person. And that also gives us some, you know, additional kind of power, which we'll see in a little bit. So now I've done something kind of sneaky, and I've created a way of comparing Mitch and Serena. Before I had that function people equal, now I can use the double equal operator, which is something that we're used to. We use it with all the other types. Why don't we use it with people, right? The way that we define that is that on this person class, I've defined this function underbar EQ underbar, right? The underbar methods and underbar init is one of them, have a special significance in Python, right? So in this case, the underbar EQ underbar says that if I have an object, Mitch, and I have a double equal, and I have another object, Serena, it's going to look in the Mitch object, and it's going to say, does it have an EQ method? Does it have this method name? And in this case, it does. So it says, okay, this object is capable of comparing itself to another object for equality. And so it calls this method, and self in this case is the Mitch object, is this guy, and other is the Serena object, sorry.
So when it looks for the EQ method, does it look for EQ or does it look for something that has a double equal sign and then go up from there? Like is the underbar EQ underbar, like is it defined for all?
It's defined for all persons.
All persons.
Yeah. Well, okay, I see what you're saying. Is it defined for objects other than persons, like all objects?
Yeah.
Well, we can check that out. So you notice that person inherits from object. This is where all classes that you define should inherit from. And so object, like any other type, remember I showed the dir command before? If you do this, you can see everything that's inherent to an object. So in this case, it doesn't have the underbar EQ. So it might be something special that Python does. So this is where I'd actually have to look it up to answer your question. So I'm going to punt on that.
It knows somehow to look for EQ specifically.
Yeah. When it sees the double equal sign, it knows to look for EQ. It's the double underbars signify a magical operator or a magical method.
So when you're calling EQ, you're definitely not giving it. You're not formally giving it two formal parameters in the parentheses notation. So it's presumably taking like the first thing before the equals and the second before the equals. And
We're getting to that. So the question is are we actually explicitly passing two formal parameters to it? And the answer is yes and no. This is a bit of syntactic sugar for Python, which means that it's a nicer way of writing things, but we could do something like this. which is totally awkward. But in actuality, this is what Python does in the background. It does this sort of kind of mangling. And I was actually going to show that with something a little bit easier to comprehend. So I have a method called getAge, an accessor, right? And usually you call a method by having a reference to the object, dot, and then whatever method name, right? In this case, getAge. You can also write it like this, which is, if you think about it, exactly what happened with the double equal operator, right? Python took your nice intuitive syntax, Mitch, double equal Serena, and totally mangled it and made it something that was completely ugly. And this is how Python would actually see it. So that's why when you write these methods, you have a self parameter. This self parameter is like this guy, right? Python says, ooh, I have an object reference, and they're calling a method getAge. Do I have a getAge method? Yes, I do. Here it is. Okay, now I'm going to take this and make it look ugly. It's a person object, so I'm going to call person.getAge, and then I'm going to pass it Mitch, the reference to the object, and that becomes the self parameter. So that's where the self parameter comes from. There's a little bit of mangling that goes on, and it's partially hidden from you. In other languages, it's completely hidden from you, but in Python, you see some of the ugliness.
So in this case, how did Python know that self was Mitch and not?
Serena?
Yeah.
So the question was, how did Python know that the parameter was Mitch? Because, let me comment this out so we know explicit what I'm talking about. So Mitch is a reference to a person that is, represents me on a computer, right? Python knows that this object is of type person, right? Because it chunked that memory and made it of type person. So when it sees this reference and it knows it's of type person, it says, and it sees this dot and getAge, what that automatically tells Python is, hey, this instance of person is trying to call a method. Does this class have a method getAge? In this case, it does, right? So Python says, oh, it does. So I am going to call this method person.getAge and pass it Mitch as a self parameter. So does it make sense in some way?
So it basically allows you to put in the name of the person instead of the action, instead of using the name of the type.
Yeah, you could do this. I don't recommend that you do this. I'm trying to illustrate where the self parameter is coming from. It's, it's much cleaner to write this than it is to write this. Fewer keystrokes too. Remember, programmers are lazy. So, but it'll do the same exact thing. So, can I move on now? All right. Wow, I've only got 3 minutes left. I don't think I'm going to be able to get through this. So my intent with this code was to show inheritance with shapes, because that's kind of the classic. I'm going to define a base class called shape, and I'm going to give it some methods: area, perimeter, EQ, and less than. For my purposes, shapes are equal if they have the same area, and they're less than if the area is less than. So when we're doing logical comparisons, we're comparing areas. So now I'm going to define a class rectangle. It inherits from shape. All right. It's got two sides, or the lengths of two sides, right? So the area is pretty easy. It's a multiplication. And the perimeter is just the sum of the four sides. And then I'm going to define another shape, circle. It's got a radius, and it does the area and the perimeter in the way that you expect a circle to do the area and the perimeter. And then I've got square, which is a subclass of rectangle, because a square is just a special case, right? And all I'm going to do is, when I initialize my square, I'm just going to make it I'm just going to call the rectangle's init method and give it the same side twice. All right. So what this gives us is some inheritance and some nice properties. So first off, when Python gets to this line, what's going to happen? S is type shape, right? So what is the method for shape? What's that?
So what is the method for shape?
What does the area method for shape do? Because that's what I'm calling here.
It's going to throw an error.
Yeah. So voila. All right. And the reason is that we haven't implemented it here. This method is it's a placeholder. It's saying that if I have a shape, it should have an area method. All right. And this is something that you should see on your problem set when you're doing PS5 with trigger.
So it doesn't do anything on its own. You can ignore it and just put an area on the circle.
Yeah.
It just reminds you.
It reminds you. Yeah.
It's like
What's that?
it's kind of like
It's like commenting, except that you get a little bit nicer error checking. So it is a way of explicitly saying that if I have something that is subclass from shape, then I can be guaranteed that there is an area method. But if I subclass off it, so rectangle, square, and circle, they all have concrete implementation for areas. So this is all going to run fine. All right, and then I have my equality operator and my lesson operator. Those will run fine. So let me. All right, and then the reason why this is useful, and kind of the big idea, is if I have a list of shapes, circle, square, and a rectangle, then I can treat them all exactly the same, because they all have an area method, which is defined on a shape. They all subclass from shape. So it'll print all those areas, and then if I wanted to, I could even, because I have a list, I can call the sort method, and because I've defined the less than operator, it'll sort the lists into ascending order, or the shapes into ascending order by area. And that's what this last bit of code does. Unless I comment out my assignment. There we go. So I know I rushed through the shape implementation, and I'm sorry, but I'm actually out of time.